Hello everyone, my name is Shubham Kothia and today I'll be presenting a fascinating new approach in time series forecasting. I'll be presenting how a tabular foundation model, TabPFN time series model, outperforms a specialized time series deep learning models. And this is part of my short story assignment and it covers a recent breakthrough using foundation models trained on synthetic data to solve a real forecasting problems without any fine tuning or large scale training. Now, here's what we'll cover in today's presentation. Firstly, I'll introduce why forecasting matters and the challenges with big deep learning models. Then we'll look at what TabPFN is and how it's extended to TabPFM time series model. And then I'll walk you through the model's workflow and performance results, followed by comparisons, strengths, limitations, and why this work matter for the future of machine learning. Now, moving to the next slide. Time series forecasting is critical across industries, from predicting electricity usage, sales demand, to forecasting traffic and financial trends, etc. While early models like ARIMA were widely used, deep learning now dominates because of its flexibility and ability to learn complex patterns. But this model often requires a massive datasets and training time. So the big question here is, can we forecast accurately without deep networks? Now we'll discuss about challenges with the large forecasting models. Modern models like Chronos or DeepAR are data hungry and computational heavy. They are also often trained on public benchmarks, raising concerns of data leakage where a model may have indirectly seen the test set during a pre-training. This issue motivated researchers to try something radically different. What if we could forecast using a small, efficient model with no time series training at all? So here it comes TabPFN. So TabPFN is a tabular foundation model designed for datasets like spreadsheets. It, it was trained entirely on synthetic data, meaning it's never seen real world datasets. Despite that, it learned to generalize remarkably well. Thanks to exposure to millions of artificially generated scenarios, it's also just 11 million parameters, making it ultra lightweight compared to a deep models with hundreds of millions of parameters. So this is a great alternative. And what is TabPFN time series? TabPFM time series extends TabPFN model to work on time series forecasting tasks. It converts a time series data into structured tabular format using a calendar based features like day of the week, month and hour. These features are encoded using sine and cosine function to represent cyclic patterns such as weekdays or time of day. Without any training on real-time series, it predicts future values with multi-step accuracy and generalizes across domains. Now let's discuss about the feature engineering. The secret lies in the clever feature engineering of this model. From each timestamp, the model extracts day of the week, month of the year, hour, and position in sequence. These are encoded cyclically to help the model recognize periodic patterns. This removes the need for RNNs or transformers and dramatically simplifies the architecture. So this is the what magic behind the TAPE-PFN. It's feature engineering. Now let's discuss how model actually works. So the full workflow is simple. As a step 1, it extracts the timestamp features from historical data. This becomes your training set. Then as part of step 2, they feed that into TabPFN, which instantly learns patterns in the tabular form. And as part of step 3, generate the same features for future time points and pass them to the model to forecast. And the result is fast, accurate predictions even in zero shot settings. So this is how it works. It is very simple to work. And now let's discuss about the performance results. So for the performance result, the TAPE-PFM time series was tested on 24 diverse datasets from domains like finance, energy, retail, and transportation. and it achieved an average MASE of 0.759, mean absolute square error, which is very low, better than Chronos Large, a 710 million parameter transformer model, and Chronos Mini, Deep AR, and TFT, even Auto ETS, a classical statistical method, and all of these form a model that's 11 million parameter and train on synthetic data only. That's incredibly efficient, both in training and inference. Now let's compare the model. Here's the visual comparison. TabPFN-TS time series model outperforms all other models. Despite being the smallest, the only one trained on zero real-world time series, the fastest to use, no training time needed. This shows that size isn't everything. It's about how you use features and whether your model can generate these challenges. The current trend of bigger is better in machine learning domain. Now let's discuss about the strengths and limitations of this model. So the strengths are light, it's very lightweight, just 11 million parameters, and no fine tuning needed. Plug and play. The fast inference deployable on limited hardware. It generalizes well across domains, but there are limitations too. It doesn't use lag based input, so it might miss recent momentum. It's a local model, no cross series learning. It doesn't support external covariates like weather, pricing, etc. And it's not ideal for very large time series, but despite that, for many use cases, especially where speed and simplicity matters, the TAP PFN time series is the game changer. The key takeaways and future directions are smart feature engineering plus foundation models can rival a large specialized deep learning architectures, and we don't always need RNNs and LSTMs or transformers for time series tasks. And training on synthetic data works really well, and it avoids privacy and leakage issues. And foundation models might soon become general purpose forecasters, just like GPT became the go to for the text. And this paper pushes us to ask what else can we repurpose foundation models for? And that's really exciting part. And here are the key references. I've cited the main paper and supporting models like Deep AI, TFT, and Chronos. And you can find these links in Medium articles and GitHub README for your reference. And thank you so much for your time and attention. And I hope you enjoyed this look and how a small foundation model like TAPE PFM time series is shaking up the forecasting world. And I'd be happy to answer any question. And you can check out the full Medium article, slide deck, and video through my GitHub. You can scan this QR code and you can access my GitHub repo. Have a great day, everyone. Thank you so much.